So for our last topic, we're going to be looking at selecting a regression model for data. Nonlinear regression is the process of finding a curve of best fit for data. Desmos can be used to perform linear and nonlinear regression to obtain the equation of best fit. The only types of regression that we will use are either linear, quadratic, or exponential. So how do you know what type of regression to use? Always use linear regression unless the scatter plot shows a curved relationship. If the graph is clearly curved, then we will use what's called the coefficient of determination, or R squared, to determine if you should use a quadratic or exponential model. So the coefficient of determination. The coefficient of determination can be used to determine which type of nonlinear regression best fits the data. The coefficient can have values from 0 to 1. And for our purposes, the best type of nonlinear regression for a particular set of data will be the one with the highest value for R squared. Or in other words, the closest value to 1. So let's go through a few examples. Example 1. In a physics project, students drop a ball from the top of a 150-meter cliff and measure the distance the ball traveled every tenth of a second for 1 second. Part A. Determine the best model for the data using Desmos. And Part B. Predict how far the ball will fall in 5 seconds. At this point, pause the video, copy this table of values into Desmos, and create your scatter plot. So Part A was determine the best model for the data. So first off, you see it's not linear by inspection, so we're not going to apply a linear regression. Instead, we're going to try both quadratic and exponential. So over here you see my quadratic regression and my exponential regression. The values for A, B, and C for the quadratic are given here, and the values for the exponential, A and B, are given here. But the important part is to look at the R squared, the coefficient of determination. And you can see that for the quadratic regression, that the R squared is closer to 1 than the exponential regression. So a quadratic relation is the best model since the coefficient of determination is closest to 1. Therefore, the relation that best models the data is given here. Predict how far the ball will fall in 5 seconds. So using the relation given in Part A, we're going to let x equal 5. So we sub 5 into our quadratic equation, and we end up getting that y is equal to 122.38. Method 2. So using Desmos, we can graph the equation x equals 5 and then find the point of intersection of x equals 5 with our quadratic relation. And again, you see you get 122.38. So therefore, it is predicted that the ball will fall approximately 122.4 meters in 5 seconds. Example 2. The local ice cream shop keeps track of how many ice cream they sell versus the noon temperature on that day. Here are their figures for the last 10 days. Again, Part A, determine the best model for the data. Part B, predict how much money the ice cream shop will generate when the temperature is 20 degrees Celsius. So again, pause the video, copy the table of values into Desmos, and create your scatter plot. Part A, determine the best model for the data. Since the graph is not curved, we're going to assume the relationship is linear. Using a linear regression, we see we get the following A value and the following B value. So therefore, the relation that best models the data is shown here. Part B, predict how much money the ice cream shop will generate when the temperature is 20 degrees Celsius. So method 1, use the relation given in part A. If we sub 20 into our linear equation, we end up with $382.57. We could also use Desmos. We're going to graph x equals 20 and click on the point of intersection of x equals 20 and our linear relation. And again, we get 382.57. So it is predicted that the shop will generate approximately $382.57 when the temperature is 20 degrees Celsius. And last example. A lab monitors the growth of a bacterial culture by scanning it every 4 hours and estimating the number of bacteria. Part A, determine the best model for the data, and Part B, predict how many bacteria there will be in 48 hours. So one more time, pause the video, copy this data into Desmos, and generate your scatter plot. Determine the best model for the data. So right away you see it's nonlinear by inspection. So the graph clearly looks curved. So that means we're going to apply a quadratic and exponential regression. So here's our quadratic regression, here's our exponential. Again, to test which one is better, we're going to look at the r-squareds. And we clearly see that the exponential has an r-squared of 1. So therefore, an exponential relation is the best model since the r-squared is closest to 1. And therefore, the relation that best models the data is shown here. And here's where I ended up getting the a value for this equation and the b value for this equation. Part B, predict how many bacteria there will be in 48 hours. So method 1, use the relation given in part A. So we're going to let x equal 48. We'll sub 48 into our exponential regression formula. And we get that y is equal to approximately 3.2 million. Using Desmos, we graph x equals 48. We highlight the point of intersection of x equals 48 and the exponential relationship. And we get again approximately 3.2 million. That 10 to the 6, so it means move your decimal place over 6 places to the right. So 1, 2, 3, 4, 5, 6. So approximately 3.2 million using Desmos as well. So it's predicted that there'll be approximately 3,213,000 bacteria in 48 hours. Here are the questions that you should try.